I'm going to try to go fast. To not take too much time. So I basically wanted to know if there's a bike when I want to take a bike in the city bike station. What happens, like, when I used to live in Lyon, they were saying, like, oh, the city bike share system is coming, it's the first. The first from where we don't know, but but it was the first. It happens that it was not the first in the world, and because the first in the world was actually invented in Holland, in Amsterdam, in the 1965, and all the bikes got stolen. And that's why there is several experiences like that in the 60s and 70s. I never go anywhere because every time all the bikes went stolen. And until Portsmouth in 1995, where now you can try the bike, so you can actually have a viable bike system. And since then, yeah, we do like animation here. The system developed everywhere in the world, and so as you can see, it's really prominent in Europe, but you also have a big system in China. America still has some work to do. But I mean, it's coming, it's coming. So, what's happening is, like, I took this data from the city bike system. It's like 18 CSV, one for each month between July 2013 and December 2014. And the full data set has around like 13 million rows. It's composed of, for every bike, so you have a bike ID, you have the duration of the trip, the start time, the stop time, the ID for the station where the trip began, an ID for the station where the trip ends. And you also have like some data about the users, whether they have subscribers or not, and their gender and so on. So first I added some variable, like the length of the time, the length of the bike stay in a station. Like you put your bike back in the station, how long it stays in the station before somebody else takes it. And I put some Boolean to know where if the travel were during rush hours, weekends, nights, such thing like that. Then stop. All up here, yeah. I also look at the distance between stations to have an idea of the data, and I was able to see like some speed were ridiculous. So there's some problem with the data they give. Like I had some bikes going 100 meters a second, which seems kind of crazy. And you can do a little exploration. You see bikes are used almost the same every day. It's actually a little bit less on the weekend, but that's not that much less. Mostly male use a city bike. There's not a lot of female using them. And most users are subscribers. Going from that, you're like, what is interesting? What can I ask to this data? The first thing is like, is there a problem? What is the problem? And my problem with the city bike is like, is there a bike in the station if I want it? Because I go try to have a bike and I can't find it. So I wanted to try to see if I could predict it. So first I did some visualization because to see if there's some difference I can catch on visualization. If there is none, it doesn't make any sense to even try to do a prediction. And if you look at the distribution of the time a bike stays in a station, it's a bit longer on the weekend. You can see also some difference between the hours with longer stay during the night, which kind of makes sense. And you see also difference between the months with same, like longer stay during the winter months.
So what's stay length? What is stay length?
It's like the time the bike stays in a station before being taken.
Like an individual bike?
Yeah.
Like, okay.
Yeah, it's tracked individually. And of course, in what stations they are, like it's probably today different than they are in the financial district and in Brooklyn somewhere. So I bin the type, each bike stays in each station by 10-minute blocks, which means my data got really big. And so that's basically, that's basically what my data looked like at that point. I have the station where the bike is, the month, the hour, some Boolean, and the block by 10 minutes, and the day of the week. So I wanted to build a GBM model. I actually tried other models, but they were not as good, so I kept that one. And I tried to do a model with all my data, and it was way too many data, I could not do anything with them. So I grouped them per day of the week. So every Monday of a month is grouped together, every Tuesday and so on. I tried to bin the number of bikes, like for example, 0 bike, is there 1 bike, is there between 2 and 10, and I tried several patterns like that, but it didn't work really well. So I finally decided to just try to see if there is 0 bike or 1 bike, at least 1 bike in any station. And I fit a different model for every month, because like I said, the size of my data was too big and I could not do it with all the data. So basically that's what it looked like for the ones that are interested. I use a GBM with a Bernoulli distribution. Number of tree of 500, interaction depth of 9, shrinkage of 0.1. And after I did that, I was like, oh, that's awesome. I have relatively good model from the summer months. However, like as you can see, this is August, I think. I have like a sensitivity of like 0.78 or a specificity of 0.74. It's not too bad, considering I don't have the weather data. But in the winter, it was really bad. And I looked at my test set, and I have a lot more data, a lot more stations with 0 bike, a lot more time with 0 bikes than with 1 bike. So I tried to look, it was the same in my train data. And as you can see, you have a lot less bike ride during winter. So you should actually have more bike in the station if you have less bike ride. So I look if there's less bike in circulation, looking at the different IDs, and there's the same number of bike. So it's really strange. And if I look at whether there's a bike in the station, I do have less bike in the winter than in the summer. And it's really strange. So it means that either there is problems with data, or maybe they take bike for reparations, they assign their ID to other bikes. But it's really strange. But to try to have a better model, I try to find a solution to this data imbalance. So first, you can put different weight on your different class when you use a GBM model. I tried that, it didn't work at all. So I tried to upsample my data, and that worked relatively well. It improved the model, and I was able to try like different number of trees, interactions, and shrinkage, and find like relatively good model for all of my months. It's still better in summer than in winter, but at least it's not chance. Since my accuracy between 0.72, that's probably February and similar. So then the goal was to, of course, you have to refresh it all the time. I did a little shiny app with this data. Like that you can like, if it loads, you can like select a day, and you can select a time, and you can look at your station, and you can also change the bin if you want. See the change, there is a bike or there is no bike in every station. With the prediction I did, which are not the best in the world, let's be honest. Because I think if you wanted to want better prediction, you would need to integrate the weather data. Probably you should integrate also the plan work data from the MTA, the big shows, game, convention data that you can find relatively easily. And finally, you may want to look at other variable engineering you could do. Like, if I had a lot of bike yesterday at 5 p.m., there's probably a better chance there's a lot of bike today at 5 p.m. too, which I didn't look at. But that would probably help the model. So that's it. I hope I was not long. And yep, if you have any questions.
I do know that they take bikes from some stations by truck.
Absolutely, they do that, but they remove it, all this data, they remove it from the data sets. Okay. So they do some cleaning on the data set. So there is some problem in the data.
Yeah, why would they remove? Any plausible reason they would remove?
I don't know, they just say they remove it. So
maybe it's because it's not keyed by a user, or it's like a system account that checks the bikes out or something?
I don't know, no, I think they have it, but they clean it because I don't know why. So, which means the data we have are already pre-processed somehow. So, and there's obviously a problem, like you can't take 60 seconds to go to financial district to Hell's Kitchen. It's just not possible, it's not happening. And stuff like that. So it may be to their pre-processing, it may be to some sensor problem, I don't know. And you also find bikes that are rented for like more than a week, which seems a bit strange. Well, I guess it's possible, but and I was thinking maybe they are not subscribers; they just take the bike and they don't care. But most of these really long renting are from subscribers, so it's a bit strange.
What percentage? Oh, sorry. What percentage of the data had 100 meters per second that were traveling incredibly?
I mean, that was my biggest one, but it was actually a good percentage, about 5–10% of the data had like pretty speed. And I can only compute the maximum speed, which is not even realistic. So no, it was actually quite a lot. I was surprised.
Did you see any clustering in the data whereby directionally most of the bike paths went from west to east or?
I didn't look at that at all, so I can't. I just look at the time they were staying in the station. I didn't look at where people were going. I'm sure people have done that.
So the prediction was time of day and station, or?
Time of day, yeah, station, months, I mean, all of that, weather. I also included whether it was rush hour, night, and which kind of is correlated to time of the day, but it gives you a bigger class. That's the only data I had. I mean, I think weather would be really a good addition.
You said that you had to do some data wrangling. How dirty was the data? How easy was it?
The data is really clean, but I had to totally transform it because it's a CSV, it's really clean. But I had to transform it because the idea behind the data is like looking at the travels that people do with the city bike, and I wanted the opposite. I wanted the bikes along the station. So I had to totally calculate that. But the data are really clean, can go to CSV, it's really easy.